So first, thanks to all of you for taking the time to come here today, and to those of you viewing online. So we spoke about DevOps for the past few days, and what I want to do is I want to share with you what DevOps means to me. Now, so as the name implies, it's about taking dev and taking ops and putting it closer together. About putting more dev into ops and more ops into dev, and that's definitely part of it. But it's not about org structures. It's not about methodologies. It's really about a team coming together, breaking down silos, and agreeing that they're all here to deliver a great service. And so for me, DevOps is really about delivering great online services. It's really a state of mind. So a little bit about myself. As Sam mentioned, my name is Chris Hanaoka, and I lead the development and operations for Microsoft's Global Foundation Services. Global Foundation Services is responsible for the strategy and the delivery of our foundational platform for cloud services, as well as the 200-plus online and live services, including data centers, networking, security, infrastructure, applications and tools. That's me. As well as operational management and environmental considerations. So one thing about online services is that, well, for me anyway, I started back in the 1990s working for Ask Jeeves. I spent about 8 years there doing various development work. About 5 years ago, I joined Yahoo. And at Yahoo, I was responsible for the production engineering of the advertising systems. And I had the pleasure of joining Microsoft a little over a year ago. And it's a great opportunity here at Microsoft because it allowed me to take my software development and my operational experience and apply it at Microsoft's scale. So I'm going to be sharing today my top 10 lessons learned in the online services space. And hopefully by the end of it, you'll also agree with me that aside from all the things online services are, at the end, it really is a state of mind. So I want to start with the 3 things I can pretty much guarantee for online services. And those 3 things are that hardware will fail, software will have bugs, and people will make mistakes. And so before we even start, it's important that everyone accepts this to be true. Any non-believers? Okay. So we call these the 3 inevitabilities of ops. So lesson 1. So again, before I was working at Ask Jeeves, I spent quite a bit of time in traditional packaged software. And I think back then, I didn't fully appreciate how different packaged software and online services really was. An analogy I like to use here at Microsoft is to really think about whether or not we're in the business of building power generators or whether we're in the business of delivering power. In Microsoft's case, both. We have packaged software and online services. But it's important to recognize that these 2 are very, very different. For example, if we're in the business of delivering or building power generators, a measurement of quality would be something like MTBF, or mean time between failures. If a generator fails after we've shipped it, it's very expensive to fix. Quality, if we're in the business of delivering power, is more about availability. You just want to make sure that when you wake up in the morning and you plug your toaster into the outlet, if it's not already plugged in, you rely on power to be there so you can have your breakfast. And if you think about the investment areas between these two businesses, they'd be very different. You'd want to invest a lot of time if you're building power generators to make sure they don't fail. A lot of R&D, making sure the components are reliable. But if you're in the business of delivering power, you don't want to invest in making sure there aren't any failures. You really want to invest in making sure you have the proper instrumentation, that you have a grid that can recover from failure, that can compartmentalize problems. And quite frankly, you shouldn't care if you have blocks of generators that have a lot less reliability than consumer power generators. Another big difference here is if you have power generators, who's responsible for making sure it keeps on running? It's the consumers. If it runs out of gas, it's your fault. If you're in the business of delivering power, the power company is responsible for making sure that you always provide the power. And so fundamentally, that's again a big difference between packaged software and online services, where Microsoft traditionally has been great at being able to hand over enterprise software and have all of you run it. And we also have to internalize and get really good at online services so that we understand that when we provide online services, we're the ones responsible for running the service, not you. So the key takeaway here is forget everything you know about packaged software. Not really. But at least sort of free yourself up from packaged software. Think about what it means to have a successful power company. And then go back and we can kind of learn and leverage some of the best practices that we've learned over the years about from packaged software. Lesson number 2. At scale, everything breaks. So I've been in a bunch of postmortems in my time. Typically we have these after any sort of outage. And especially my more operational role at Yahoo, when I first joined, I would hear things like, "Oh, don't worry about that, Chris. It's 1 in a million. Wouldn't happen again." It was an edge case, or it was a fluke dormant bug. There's some other things that I've heard, and I've got to be like the luckiest man alive because that 1 in a million happened quite often. And I think that's one of the key things about scale is you have to realize that things breaking for things that you don't expect is the absolute norm. If you think about some of the hardware, the network devices, we really tax them at scale. We uncover bugs and scenarios and race conditions that just you don't see in an environment that doesn't have our scale. And so really, what you have to do with this notion that at scale everything breaks is 2 things. The first one is to say things are going to fail. So handle the failures gracefully. You heard Mark talk about some of the things that they do in Azure. But what you want to do is you want to think about saying, assuming everything fails, let's make sure there's graceful degradation. Let's make sure that we have the minimum impact on a specific service based on certain types of failures. And so that's one thing in terms of the mindset. And this goes all the way, not just from an operational standpoint, not just from a development, but fundamentally, architecturally, from the service perspective, what happens when certain components start to fail? That has to be designed up front. The second piece is what's called recovery-oriented computing. And the idea is that everything you depend on could fail. So how do you engineer your software to accommodate for the fact that disks go bad, a service that you depend on stops working? There's a lot of literature around recovery-oriented computing, but it's something that you really have to embrace and practice when developing online services. I think one of the pitfalls and Microsoft was definitely guilty early on, was to say that, well, let's just have more resilient infrastructure. Let's make our data centers more reliable. Let's make our servers more reliable. And the reality is that's very, very expensive. And it doesn't really work. And so, I think the key takeaway for lesson number 2 really is to accept that high availability, resiliency is a software problem. It has to be written in the code. All right, lesson number 3. Business cannot stand still. So who knows why cars have brakes?
So you can drive really fast.
That's right, so you can drive really fast. I couldn't find a great fun picture of a car brake, and so instead I got this toboggan. And you'll notice the father and his child there are smiling, and they have this nice little handbrake in the middle. Now imagine if they didn't have that brake. Most likely, they'll be on a much less steep incline, maybe even sort of pushing themselves down, because they can't go very fast if you don't have a brake. It's probably not so much fun. And I like to think about this when we think about designing software. In the traditional enterprise IT space, there's this positive tension, maybe not always positive, between dev and operations. So dev typically wants to push a whole bunch of changes out. And ops says, no changes, because ops is all about stability. But that doesn't really apply in the online services space. We have to be able to get changes out quickly. So what we have to think about are things like brakes. What are the kinds of things that we can do to allow us to go faster? So one example are things like instantaneous rollback. Everything that we deploy, we should be able to roll back instantaneously. You want to have this whole notion of maybe a staggered rollout or dialed rollout where you deploy 5%, 10%, 15%. If anything goes wrong, you can roll it back instantly. There's this whole notion of continuous deployments. For example, Bing has many experiments going on at any given time. And the idea is that based on the understanding of each of those experiments, they're quickly able to basically roll back certain experiments, deploy new ones. You've probably also heard about things like testing in production. And that's not to say that you want to be careless and just throw everything out in production and see what breaks. There's obviously some testing that if you can do beforehand, you want to be able to do. But it's also realizing that at the end of the day, the solution for deployment in the online service space isn't about slowing down changes. It's about how to safely speed up deployments. So the key takeaway for lesson number 3 is that we have to invest and become exceptional at managing change in production. So lesson number 4, simple things are easier to get right. So I was trying to think of an analogy here, and the thing that resonated most with me was a quote from Mark Twain. It says, "I didn't have time to write a short letter, so I wrote a long one." And if you think about it, it really does take more time to write a short letter. It's a huge investment to go back and constantly refactor your code to make it as simple as possible. Now, simple things are easier to get right. They're also very, very expensive. One of the notions we have here at Microsoft is this thing called tech debt. And what tech debt is sometimes we have to make compromises to make sure that we can actually get certain features out to market. And the cost of this tech debt is usually an operational cost. Maybe a little bit more complexity. It's just a bit more expensive to run this piece of code. But we're very diligent and disciplined about going back and saying, okay, well, we got these features out. We've got to go back and pay down our tech debt. And so you have subsequent releases that focus on simplifying the deployments, improving some of the instrumentation. There's also things that the software development teams can do, which is to really write a lot of inwards-looking functionality so that you don't, it's a much more difficult problem if you think about all the people who are actually dependent on you. It's much easier to basically say, hey, I don't know who depends on me. All I know is if I'm not operating or I can't do what I'm designed to do, I'm just going to fail. And if everyone goes, going back to the previous lesson, thinks about saying, hey, I'm going to be dependent on these services, components, but they're going to fail fast, and I can handle that because I'm expecting it. It order of magnitude simplifies the complexity in running very interdependent online services. The other sort of tip that I think is sort of a quick win is making the installs easy. Now, a lot of times with online services, you can actually make a very, very complex installer that starts this, runs this scripts, starts this, stops this, changes the database schema, rolls out a whole bunch of sequences of code. And the problem with that is if anything fails, you're not quite sure what the state of a production machine is in. And so, one example or one tip in making installs easy is to say, hey, design your software so you can actually have simple X copies that gets deployed. And when you're ready, you can simply stop the service and restart it. It's usually pretty easy. Sometimes it's not so easy. But again, if you think about it, there's just a whole bunch of problems that you don't have to deal with in terms of getting manifests for current state of production machines. Because it's pretty clear that once, if you're basically pointing a symlink to a directory and you restart a service, you're on version 2. And if it doesn't work, you basically flip the directory, stop the service, and restart it. And so that's an example of one of the things that we do to keep things simple. So again, simplicity is not cheap, but it's an important investment because otherwise the online service environment, the production environment is just going to get way too complicated. Lesson number 5. People make mistakes, people need sleep, and people forget things. I didn't think this was the case for me when I was younger. And now I realize that this is actually even more the case. I need a lot more sleep than I used to when I was in my 20s. But the important thing here to remember is let's let computers do what they do best. It drives me nuts when we actually have postmortems where the remediation item is to change our process and to make sure everyone knows what that is. In some cases, that's fine. But we always want to look for opportunities to codify some of those controls so that we don't have to rely on our memory and our processes. We don't have to rely on people. So here's some bullets of some of the benefits of automation. Testable, fixable, reliable, scalable, and cost-effective. Just a few examples. But the key thing is whenever you kind of go and say, you know what, we've learned something, we want to operationalize something, always think about automation first. That's the only way anything at any major scale would scale effectively. All right, for all you Spider-Man fans out there, lesson number 6, with great power comes great responsibility. Who here remembers Fat Finger Thursday? Ah, okay, not too many. Fat Finger Thursday was May 6th, 2010, when the Dow dropped 600 plus points because somebody entered a trade for 16 billion instead of 16 million. Do you remember that day now? Whoops. How many of you have heard of MTBHD? Mean time between horrifying discoveries. And so previously, I mentioned that automation is really important, But you also have to realize what automation can do. Automation can become a weapon of mass destruction. And so, along with ways to be able to manage change more effectively, you also need to think about what's the right way to leverage automation, but also to protect yourself from automation in any sort of large-scale online service. That can include things like fault zones. It can mean that you basically have, you compartmentalize some of the code, so you have to actually, even though it's automated, you've got to have an automated deployment 10 times as opposed to once. This whole notion of fire breaks, et cetera, are key to just making sure that you avoid these massive failures. And unfortunately, these do tend to happen every now and then. And not all of them are preventable. But again, just respecting what automation can do in a bad way will hopefully make sure that your MTBHD remains high. All right. Lesson number 7. You can't hit what you can't see. So in online services, it's typically not one exe, one script, one page. It's very, very complicated. And when something goes wrong, it can be very, very difficult to find out what's wrong. You don't have the luxury of having a debugger in most cases. And you don't necessarily have the time to do a lot of exhaustive testing in a lab environment. What you need to do is you need to accept that you're going to basically be confronted with some things that are unique in a production environment, and you have to be prepared. So that means instrument everything and know what that instrumentation means to you. So whether or not it's traffic, the number of users, the amount of memory, all these different services in terms of, in the search space, queries per second. Understand how each of those metrics are affected as you traverse the entire dependency tree of that service. The other thing is you have to really monitor for a tight range and then start loosening up. Because a lot of times the most difficult, or in almost all cases, the most difficult type of failure to detect are those gray ones. And so, if you actually keep it tight and you figure out what kinds of telemetry, it tends to be noise, you go back, you refactor the code, try to reduce that range, try to keep things as tight as possible. The other thing is, if you actually instrument everything, in the event that you actually do have some sort of incident or outage, you can go back and you actually have numbers that you can look at in the future to help you detect things early on and to prevent things from happening again in the future. So the takeaway here is instrument everything. You can't have too much data. Lesson number 8. If it sounds too good to be true, it probably is. So everywhere I've worked, there's a tool or an application or a system called MCP. For those of you who aren't Tron fans, there's this thing called the MCP, Master Control Program, that managed everything. And every place I've worked, people have aspired to basically say, you don't have to do anything. Everything is completely automated. And I think we're definitely getting closer to that. But it's also important to remember that there's no silver bullet. And especially for online services, no matter how much you automate, you must remain disciplined when it comes to things like change management, incident management, problem management. Even those little things that you find, just one extra, 5 steps you can actually automate, ways to add one more piece of instrumentation. Even though you can't prevent all incidents and outages, you can pretty much guarantee that you'll constantly improve if you have this discipline. And as I say there, every single opportunity to improve the people, process, and technology is going to have a huge payoff, because every second counts when it comes to any sort of outage with an online service. Lesson number 9. Battlefield doctors decide who lives and dies. So how many of you have actually been on incident bridges where something's wrong, your customers don't have some sort of service, everyone jumps onto a bridge to try to figure out what's wrong? All right, so a good number of you. It always surprised me. Some of that happened when I was with Ask Jeeves. It became a part of life when I went to Yahoo, because I was in a much more operational role. And the first thing that you should hear on a bridge is, so, what's changed? Which is why it's important to have that operational discipline before. Because typically, changes are what leads to most of the outages. Things you don't want to hear is crickets. And then somebody just sort of madly typing in the background saying, try it now. Because again, that means you don't have operational discipline. Other things that you typically hear, it's a networking issue. For online services, every single incident is a networking issue. I feel bad for those guys. And typically it's not. The key thing with that bridge is it really sort of helped me internalize that there really is sort of a fog of war when it comes to a live site incident. After the fact, you can kind of go and say, it's obvious. It was A, B, it was this router went bad, or this piece of code wasn't installed correctly. At that time, almost every possible networking issue comes up as the root cause. And even when we understand what's wrong, you would have developers kind of say, wait, I want to collect more forensics here. Don't restart the service. Which is why you need to have an operations center, a central command and control, who understands that in the online services space, service restoration is priority number 1. The closing comment there is, I've had the pleasure of working with a lot of great developers. Weren't very good crisis managers at all. Much more interested in trying to find out why something didn't work as opposed to trying to get it to work again. So, central command and control. All right, lesson number 10. Practice makes perfect. So, if you have a fire and you call the fire department, you don't want the firefighters to go, what should we do? You want them to have practiced and practiced and practiced, so when they come, they know exactly what to do. Thank God for online services at Microsoft, there's not always an outage. But it's important that we constantly practice so that when there is one, we don't have to think about things on the spot. Fundamentally, outages are stressful situations. There's a lot of pressure to get things resolved. And you want to be a fireman who's well-trained. I think one of the most useful operational capabilities that anyone can have is the ability to fail over. if you can fail over seamlessly, it makes life so much easier. If there's some issue with the data center, a potential maintenance because a PDU has gone bad, and you don't want to basically be operating a service without a safety net, you basically fail over to another data center or to another part of the data center. And you want to do that often, not annually or quarterly, but maybe weekly. Of course, not if it interrupts your service. But then you can take that back to the developers and say, it's really important for us to have the ability to fail over seamlessly. Another thing is changes. I mentioned that changes are the #1 causes of outages. And so as opposed to slowing down, we want to speed up, and we want to deploy constantly. And the last one, in the different various places I've worked, has always been high on the list of things that people should do, or we knew that we should do it, but actually didn't, which is data restoration. It's interesting that we back up to tapes, just like a lot of other people. But really, a lot of the purpose of those backups on tapes isn't really so much that we can actually restore data in case there's actually a hardware failure. The times we have to restore data is when there's a software bug that introduced bad data maybe weeks ago. And we got to go back and try to fix that. And tape backups are actually a very economical way to preserve data. But it always surprised me that it wasn't really there for when hardware failed. It's really there when a software bug got introduced and we didn't catch it right away. Having said that, it's really important, especially in those cases, that we're able to restore the data reliably and quickly. So practice data restoration. An online service is, whether it's all the operational discipline, failover, changes, deployment, it's about practicing, practicing, practicing. So those were my top 10 lessons. Do you remember the 3 inevitabilities of ops? Hardware will fail, software will have bugs, and people will make mistakes. Don't try to prevent it. Just accept it. Engineer around it. Here at Microsoft, we understand that delivering great online services really is sort of a state of mind. So thank you, and I have some time for some Q&A.
Questions for Chris? Sorry, I'm not as good a Phil Donahue as Keith, but here goes.
I'm kind of curious, your portfolio of software tools you're using to run your services. I mean, are you guys developing your own stuff or using TFS, Microsoft Manager, managers?
There's a proliferation of tools within Microsoft. In my space, a lot of it is very specific to physical infrastructure, so we develop a lot of that. But definitely from the software services perspective, TFS is a big tool a major tool that we actually use. Azure in general, the tools that Azure has to offer for a lot of our service development. And then we have various deployment and monitoring solutions within tooling within Microsoft. Some that's commercially available and some that are also internally developed.
So are you using any type of agile methodologies to manage your team, maybe Kanban?
So I think there's a lot of teams out there. My team specifically, we have a version of Agile. As Mark was talking previously about releasing things on a cadence, we happen to have a monthly train cadence. But there's also a lot of teams who are deploying constantly. And I think the goal is to be able to get to the point where we have enough operational maturity where we can just constantly deploy. I think the goal is to be able to deploy constantly. Now, part of it is the point of diminishing returns. It just the benefit, at least from my team's perspective, of deploying every single day isn't nearly as great as a lot of the services that face you guys. And so, but definitely, I think everyone is going and trying to figure out ways to be able to deploy faster, to decouple different services, again, to be able to degrade gracefully. And that really allows things to be deployed very, very quickly. One example is Bing, which is constantly deploying and has many different experiments going on at any given time with different algorithms, et cetera, and just constantly collecting all this telemetry. Very, very mature in terms of being able to do constant, continuous deployment.
Any more? Oh, there's a question over here. I'll run you a mic. This is how I get my exercise. Once a year, I run up and down these.
Aside from failovers and some of the other things you mentioned, are there any things you would tell developers to definitely put in to make your lives easier from an operations standpoint?
I think different services have different needs. And so, availability, some of the key metrics are, time to detect, time to restore service, and also operational costs. And so with that post-mortem process, it can be something like, if it's a very data-heavy service, the ability to be able to bootstrap that data very, very quickly in case there's data corruption. Ways to be able to scale horizontally. Ways to do deployments in a simple way. Definitely failover, instrumentation. There's also a lot of transactional systems as well. So ways to be able to, I think transactional systems are probably the most difficult because you have to really think from an end-to-end perspective, not from a DBA's perspective, not from just a C# development perspective, but a way to say, if you take the whole infrastructure and the SQL database and the actual code, how do we make sure that we can actually maintain and operate and upgrade and deploy versions without any downtime? And so, I think that discipline of the operational, that operational discipline will really help gear you towards the problems that you want to be able to address from a development standpoint.
Oh, right behind you, Sam. A couple rows up.
With the question about tooling, and you said use some of the tools that are commercially available and some that are your own, and I've heard that a lot from Microsoft. Oftentimes, there's your own internal tools, and then there's what everybody else can use. And I would think it'd be a higher priority these days to always, why isn't there more of a focus on making those internal tools available? Like, shouldn't that be almost a first priority, make sure that everybody benefits from it?
Absolutely. I think one of the great things about Microsoft is that there's so many different streams of development going on that you can't always sort of build the tools and the infrastructure and the platform first and then have everyone kind of go, because a lot of the online services sort of start before the tools are even ready. The great thing is we've got a lot of great forums to be able to take the best of all these different types of tools and constantly reintegrate that. So at any given point in time, you do have a lot of focus on internal tools. You have a whole bunch of new efforts spinning up on top of that tool set. And then you have a whole bunch of folks who are sort of more sort of trailblazers going in and then trying to adopt. In the meantime, there's more changes going on in the online services. And so those may actually come up with their own proprietary tools again, and the cycle starts over again within those best practices. So absolutely. I think in areas of operational discipline like change management, incident management, problem management, it's much easier, much more meaningful to actually have consistent tools across all of Microsoft. And then there's more specific tools. It makes more sense to actually say this is a tool that serves the need of a real online service, and then we take that and productize that into a tool. But that's actually one of the questions I always asked myself when I first joined, and now I understand.
So I have a question on the right here.
Hi.
You mentioned incident management, change management, problem management. Sounds like you guys are using some of the ITIL processes. Are you finding that you're adopting more of that, or have you identified new or evolutionary processes to better collaborate with the teams that are developing and handing off the solutions to you?
So the question is whether or not we've embraced ITIL further, or whether we've sort of come up with our own flavor of ITIL. Okay. So it's kind of a hard question to answer. What I would say is that, various people feel stronger about ITIL than others. For me, what ITIL provides is a common vocabulary, and so that everyone can speak the same language when it comes to operational capabilities. And definitely in terms of some of the ITIL fundamentals, I think we adhere to that very much. Now, when it starts getting into more details in terms of the ITIL process, things like CMDBs versus CMSs, what actually gets included, and how do dependency mappings work? How do you actually define roles and roles of servers and pieces of software? I think that's where we maintain the spirit of ITIL. But again, because of just how quickly teams innovate, their particular interpretation of some of those capabilities can be slightly different. And so at a macro level, definitely incident management, change management, problem management is shared. But definitely when you get into some of the more details, we're constantly refactoring and trying to take the best practices while everyone doesn't follow exactly the same process.
Oh, got one right here in the front. I'll get him a mic.
So I have a question about network changes, and I know you're not, above that the team but so when you're automating a lot of the application deployment, how do you manage network changes? So, for example, an application needs a couple of firewall changes. Are you automating that as well, or that is happening in a more manual basis?
Both. I think going back to ITIL terminology, I think there's some normal changes that are done automatically. So, for example, we can actually be pushing ACLs. It's all automated on a schedule based on some self-service tools. And the automation itself is cutting a lot of those change tickets. So if one of those changes does cause an incident or an outage, we still have a record that we can cross-reference in terms of what changes were made. There are other things that are a bit more complex, and so we don't have that automated yet. But again, kind of going back to one of our lessons, we're constantly looking to kind of take those things that are manual, which we still have plenty of manual changes that follow a more traditional change management process, and looking to drive automation into our tooling. So the answer is both.
Looks like that might be it.
All right. Well,
Chris,
thanks again.
thank you very much.